The Hill cipher was invented by Lester Hill in the year 1929. It is a polygraphic substitution cipher. It encrypts the text by replacing the letters with other letters based on the mathematical operations, making it both simple and effective. It makes the use of key matrix. The Hill cipher relies on the square matrix called the key matrix. Its size determines the number of letters encrypted simultaneously, either in the pairs of 2 by 2 matrix or the triplets 3 by 3 matrix. This matrix is a fundamental to the encryption process. Let's see the encryption process. To encrypt a message, letters are converted into the numbers where A is equal to 0, B is equal to 1 and so on up to Z is equal to 25. These numbers are multiplied by the key matrix. The result is taken modulo 26 to ensure it stays within the range of alphabet. Finally, the resulting numbers are converted back into the letters to form a ciphertext. A simple example. Using a key matrix 1, 2, 3, 4, let's encrypt the plain text hello. The process transforms the letters into the numbers, applies the matrix multiplication and modulo operations and converts the result back into letters. The final ciphertext is CJKSR. Similar is the decryption process. The decryption involves finding the inverse of a key matrix. By multiplying the ciphertext with the inverse matrix and applying modulo 26, we retrieve the original plain text. For example, the ciphertext obtained, that is CJKSR, decrypts back to hello. Here are the decryption process. Now the strength and weaknesses. The Hill cipher is simple and efficient but has vulnerabilities. It is easy to implement and provides basic encryption security, but it is susceptible to no plain text attacks, making it unsuitable for modern use. Here are some of the applications of Hill cipher. The Hill cipher has historical significance, being used during World War II for secure communications. While vulnerable to attacks, it remains a valuable tool in cryptography education, showcasing the principles of encryption and decryption. Hill cipher. For encryption, we have C is equal to KP mod 26. C represents ciphertext, K represents a key, P represents a plain text. And for decryption, we have exactly opposite process. P is equal to C K inverse mod 26. Again, C is ciphertext, K inverse is the key. Now here a key is given to you of 2 by 2 matrix and the plain text given to you is attack. Now what we should do? We should convert this plain text into a vector of length 2 because the key is of length 2 by 2 matrix. If the key given to you is of 3 by 3 matrix, convert it into the length of 3. Based on your key, convert your plain text. Now we have converted into a pair of 2. ATTACK. Now consider the first vector, that is your first pair AT. Write it vertically and write what is the value for A as well as T. It's 0 and 19. Now according to the formula C is equal to KP mod 26. We will be writing it for the first one, that is K. This is your plain text mod 26. Firstly do the matrix multiplication over here. It comes out to be 5714 mod 26, which is equal to 5 and 10. Write down the values of 5 and 10. It comes out to be 5 and K. Similarly, encrypt it for TA and CK as well. See over here, TA and CK. And whatever the answers you get, combine it as a ciphertext. It comes out to be FK, MF and IO. So this is how you will be encrypting the plain text using Hill cipher. Exactly opposite process we will be following for decrypting the given ciphertext. Right now we have the ciphertext as FK, MF, IO. So this is your ciphertext. Again, convert the ciphertext into a pair of 2. Write it vertically and write down its values. FK, MF, IO. Write down all the ciphertext into a pair of 2 and write down its values over here. Now using this decryption formula, P is equal to C K inverse mod 26, we will be decrypting the ciphertext. So in order to decipher the ciphertext, firstly, we'll be finding out the K inverse. Formula of K inverse is equal to D inverse adjoint of K. D is nothing but the determinant of your key. So just cross multiply 2 6 are 12 minus 9, which comes out to be 3. Now find out the multiplicative additive inverse of determinant. That is D into D inverse is equal to 1 mod 26. D, it has come out to be 3. 3 into D inverse is equal to 1 mod 26. Now using trial and error method, you are supposed to find out the value of D inverse. Suppose 3 into 1, it comes out to be 1. 3. 3 is equal to 1 mod 26? No. Go for the next value. 3 into 2, 6. Is it 1 mod 26? No. 3 3s are 9. 9 is equal to 1 mod 26? No. Answer should be 1 over here. So 3 9s are 27. 27 is equal to 1 mod 26. This comes out with 27 mod 26. It comes out to be 1. So the D inverse will be 9. You are supposed to use trial and error method over here. Now find out the K. K is given to you already. It's a key 2 3 3 6. Adjoint of K will be, you are supposed to just replace this by minus sign, since it is a 2 by 2 matrix. Otherwise in 3 by 3 matrix we have plus, minus, plus and so on. Alternate signs are negative. Now minus 23, this alphabet is not present. So total we have 26 number of alphabets. So 26 minus 3, or you can take this as minus 3 mod 26, which comes out to be 23. Okay, so K inverse is now 9 into 9 was your D inverse. 9 into this adjoint of K into mod 26, which comes out to be 2, 25, 25, 18. Now find out the first plain text for the F and K. K inverse C mod 26. This is your K inverse. First ciphertext mod 26. You get it as 0, 19, which is A and T. In the same way, find it for plain text 2 and 3. Again, you get the same text as A, T, T, A, C, K, which was your original plain text.